trigonometry, finding the missing side in a right-angled triangle when we know the length of one side and one angle apart from the right angle. In this situation, we know the angle of 32 degrees and we know the length of this side here, which is 4 centimeters. First thing to do is label up the triangle to say which side is which, because that's going to determine which trigonometry function we're going to be using. We've got the y here and the 4. As you can see, the y is the opposite side, labelled in red, and the 4 is the hypotenuse side. The adjacent side is actually here, but we're not going to actually use it in the calculation, so we'll cross it out straight away. Looking here, we've got so, which has got the opposite and hypotenuse sides in it, see the colours there. So sine x is opposite divided by hypotenuse, that's the rule. So what we're going to do is we're going to substitute the information of the triangle into that formula. So sine 32 degrees is going to be equal to y, because the y is displayed there, divided by 4. Next stage is we want to get y on its own, so we're going to multiply both sides of this equation here by 4, and so 4 multiplied by the sine 32 degrees will give us what y is, and now we're going to work it out. To work it out, we'll use the calculator. First thing you do when you're doing trigonometry or anything to do with sine, cos or tan with the calculator, you must check first of all that it's always in degrees mode. So there'll be a DG stuck on the screen or a D, to make sure it's in degrees mode, that make sure there's no R or a G on it, so check it thoroughly. Okay, so 4 multiplied by the sine buttons on the top there, so in the line of sine, cos and tan, times by sine 32, so 4 times sine 32, and that gives us an answer of 2.119. I'm going to call it 2.2 centimetres length of the side. So there you have it. That's how you work out that triangle there. Let's go over to here. We've now got triangle set up. If you notice, the colours are slightly different on this. This W here we want to find, and that's actually marked in blue because it's the adjacent side, isn't it? So be careful when you turn the triangle around, make sure that you stick to your principles and label it correctly. The hypotenuse, remember, is always opposite the right angle, that's why it's in green. The adjacent side here in blue, next to the angle. The opposite side is here, and we'll cross it out because we're not going to use it in the calculation. So this calculation is focusing on adjacent and hypotenuse. So what I've done here, adjacent hypotenuse is cos, and here I've substituted that information into the equation. So cos 65 degrees is equal to the adjacent, which is our W, what we want to find, divided by 7, which is the hypotenuse. Now we're going to write out 7 to rearrange, that's how rearrange it in exactly the same way as the triangle over there, multiplied by cos 65 degrees. And the final stage then is going to be 7 times by cos 65 degrees, and that gives me 2.958. So I'll call that 2.958. That's going to be 3.0 centimetres. Okay, so that's the length of W. One last one. So you've got the triangle all sort of turned around a little bit there. We want to find the red side P. As our opposite, can you see there's your 12 degrees? It's opposite the 12 degrees. The 9.2 is the adjacent side, so it's next to it. Here's our hypotenuse, because remember it's the side that doesn't touch the right angle. We'll mark it H, but we're not going to be using it, so we cross it out. So we're left with these two, the red and the blue ones there. Oh look, it's tan there, TOA, so we're going to use tan x is opposite over adjacent. So in this case, tan of 12 degrees is equal to P, which is the side we want to find, over 9.2. you are allowed decimals. So 9.2, which is the adjacent side. Rearranging step again. Remember, we've got to multiply by that number there on the bottom, which is 9.2 today. We're going to multiply that by tan of 12. That's going to give us our answer of P there, isn't it, when we rearrange. So we'll put the P down there. The final stage, again, remembering, always check it's in degrees mode. We're going to do 9.2 multiplied by tan of 12 degrees, and that's press the equals button then. That gives me 1.955, so I can put it 1.95 or I can call it 2.0. So 2.0 centimetres. Always, I normally work these to one decimal place. So do that and let's see the question tells you otherwise. Okay, so those are 3 examples of how we work out a missing side using our trigonometry identities.